20 meter per second due north along a highway makes a right turn onto a side road that heads due east. It takes 50 seconds for the car to complete the turn. At the end of 50 seconds, the car has a speed of 15 meter per second along the side road. Determine the magnitude of the average acceleration over the 50-second interval. So initially the car is heading along this direction. Let us call this vector as v1. The value of v1 is 20 meter per second. This is 20 meter per second. And then it takes a right turn which is of magnitude 15 meter per second. Now, how do we define the average acceleration? The average acceleration is defined as change in velocity divided by the time taken. So let us find out the change in velocity, that is v2 vector minus v1 vector. So if we can get the v2 vector minus v1 vector, we can find it out. So remember, v2 vector minus v1 vector is nothing but vector v2 plus minus v1 vector. So we need to subtract the vector v1 from v2. So how do we do this? Look at this. The vector v2 is here. So I'm not touching that. And I'm going to take the vector v1 in the opposite direction. Minus v1. So minus v1 vector. This is minus v1 vector. And I'm using triangle law. Clearly, this vector should give us vector v2 minus vector v1. Vector v2 minus vector v1. Thus, from this, vector v2 minus vector v1 square is equal to vector v2 square plus minus v1 square vector. This is equal to, what is this? This is 20 square. This is 15 square magnitude. So this is going to be 400 plus 225, 625. Or vector v2 minus vector v1 is the square root of this. This is 25. Thus, the average acceleration vector is 25 divided by time taken is 50, or the magnitude of the average acceleration is 0.5 meter per second square.